Yeah, so as said, we are now talking about the significant figures. Then after I'll talk about the area. Then I'll proceed to volume. Now, significant figures in every measurement of a quantity is an attempt to find its true value and is subject to errors arising from limitations of the apparatus and the experiment. Number two, we are saying that the number of figures are called significant figures are given for a measurement indicates how accurate we think it is, and more significant and more figures should not be given than are justified. For example, a significant figure like 4.5, significant figure like 4.5, 4.5 has a two significant figure, and a significant, a value like 0.0385 has got three significant figures, that is 1, 2, and 3, whereby 3 being the most significant figure, so a significant figure with more power, and 5 the least significant figure. Now it is the one we are least sure about, since it might be 4 or 6. So we are saying that in this example, 0.0385, we've got 3, which is the most significant figure, and 5 as the least significant figure. You're saying that because we are not sure about the least, so the least could be like here, it can be 4 or 6. Now it will be a guess. Now it must be estimated by the experimenter because the reading was between 2 marks on a scale. So it was estimated by the experimenter because the reading was between the 2 marks of the scale. Now, when doing a calculation, your answer should have the same number of significant figures as the measurement used in the calculation. Now, we are saying that, for example, we are saying, for example, let me turn this way. When doing a calculation, your answer should have the same number of significant figures as the measurements used into the calculation. For example, in your calculator, when you get this, and the examiner requires you to write your answer in either 2 significant figure or 3 significant figure, you should be able to know that this whole value from your calculator can be rewritten in a 2 significant figure as 3.4, or into a 3 significant figure as 3.42. How do I get 3.4 or 3.42? Now, when deciding the least significant figure, when you want to decide the least significant figure, you look at the next figure to the right. For example, I would want to decide a least significant figure of 2. I know this is 4. Okay. Now I look the next figure to the right, that is 1, and I'll be able to decide whether I can round off 1 to 4 or it will remain. So what will happen is, if it is less than 5, then you leave the least significant figure as it is. So if the value that is on to the right, that is like 2, like 1 here, which is less than 5, then I'll leave this 4 as it is. So therefore 3.41 is just 3.4. But if it is equal or greater than 5, you increase the least significant figure by 1. So then you can round up. For 3.418, it can become 3.42. So I'm rounding up 8 to increase to 1. Then you're saying that if a number is expressed in standard notation, the number of significant figure is the number of digits before the power of tens. For example, 2.73 times 10 cubed has only 3 significant figures. So here is what we look. We don't look at the power of 10. I've done for the area, and I'm now saying that the area, because we have talked about the area in our initial video, that is in the introduction. They're now saying that the area is the measure of surface and its SI unit is square meter, in bracket meter squared. For example, the area of a square is length times length, which is length squared or side by side, side squared. Don't confuse the area with the perimeter. And then I'm now saying that for the area of the rectangle is length times width. The area of the triangle is half base times height. The area of the square is pi r squared. And the circumference of the square is 2 pi r. For example, calculate the area of the figures below. Example A, a right angled triangle of height 6 centimeters and a base of 4 centimeters. Solution, the way I told you, that when you are given the calculation like this, you first start with the formula. So there's a mark for this. Then you go to the procedure. There's also a mark for that. Then you give us the answer, which has a full mark of the value itself and the SI unit. The same to B, you give us the formula, that is half base times height, then tell us the procedure and how you will arrive to your last answer. The same to C, give us the formula, the procedure, and the last answer. I'll proceed and do a video on volume. I'll proceed and do a video for volume.